Hey guys, we're Group 12 and our project is the implementation of market basket analysis for an online retail store.
For our project, we've chosen the online retail data set available on the UCI Machine Learning Repository. The data contains all transactions of a UK-based online retail store that sells all occasion gifts. The transactions span a time period of over a year. Most customers of the company are wholesalers and hence buy items in bulk. Every row in the dataset is defined using the 8 attributes mentioned on the slide. The dataset does not consist of missing values. These 8 attributes define every transaction present in the dataset. Multiple items purchased together have the same invoice number. In order to perform a market basket analysis, we had to choose the most significant attributes out of all attributes present. In order to do so, we have chosen invoice number and product description, since these attributes help us convert our data from atomic to transaction.
Data matters. We get insights from all our data points and thus it's important to know what data we're dealing with. It helps us fill gaps in our understanding and also combine data from other available resources. In our current data set, we compare the data before cleaning and after cleaning. The data before cleaning represents the data of the online retail store in Germany. It has redundant data with missing values and attributes which impart no important knowledge to us to perform market basket analysis. This data represents the frequency of all items in the set before and after cleaning along with the number of transactions. Data visualizing is a crucial tool in today's data-focused world. A picture is worth 1,000 words and in our case 1,000 lines of data. As data volume increases, visualizing information makes it easy to find trends. These visual trends help us understand our next steps in less time and energy dedicated to data analysis. You can save time by looking at the cover of all picture instead of querying and understanding data over text. It also helps us find important correlations and relationship between attributes which we need to focus on. In our case, it helped us decide invoice number and description are the only two attributes needed as the others like stock code and quantity were either too unclear to understand or didn't seem like a fit for our requirement which was market basket analysis.
For our dataset online retail, we choose association rule as data mining technique. Association rule is the data mining process of finding the rules that make on associations and causal object between set of items. Classification and clustering will enable us to determine if the particular data point belongs to a particular class label or not. That would have been less informative than a market basket analysis. Association mining task over classification and clustering enable us to obtain knowledge about which items are frequently purchased together. So we decided to go with the market basket analysis for our dataset. Market basket analysis is a modeling technique based upon the theory that if you buy a certain group of items, you are more likely to buy another group of items. This is a method of detecting association between items that are frequently purchased together. The output of a market basket analysis is a set of association rules which establish a relation between a set of items. For our project component, we decided to perform a market basket analysis only of transactions which took place in Germany. We are making use of a priori algorithms for generating association rules.
A priori algorithm. This algorithm is frequently used to generate association rules from transactional data sets. The algorithm works on the principle of generating subsets of item sets and generating rules based on the frequency of these subsets compared against a threshold value. The association rules are generated on the basis of two factors, support and confidence. For a mining component, we have considered 603 transactions which we obtained after processing the data. We are using the A-Rules package available in R for implementing this algorithm and A-Rules Wiz package for visualizing the results of this algorithm. Support and confidence. Support is defined as a percentage of transactions that include all the items of an item set. A higher measure of support indicates a higher frequency of the items occurring together in one transaction. The computation of support requires the computation of support count, which is evaluated by measuring the frequency of occurrences of an item set. Confidence is a measure of probability. Confidence measures how probable it is for a customer to have purchased items on the right-hand side of a rule if they have purchased all the items on the left-hand side of the rule. We tweaked the support and confidence values for the same dataset and we got a varying number of rules for different values of support and confidence. We decided to set the support value as 0.1 and confidence value as 0.85 as higher support and confidence values lead to the generation of stronger rules.
Once the data cleaning is done, steps to perform market basket analysis are aggregation of the invoice and product description, which is basically getting all the product for that particular invoice where the products are comma separated, splitting the description of invoice number in separate column, performing the market basket analysis using a priori, for which libraries included are arules, arulesviz, using the a priori function, and splitting a value for support and confidence. We get rules, we then remove the redundant rules.
Knowledge gained. After performing market basket analysis on the online retail data, we have gained knowledge about the items that were frequently bought together. After careful observations of the data, we have come up with the following threshold values: support equal to 0.1, confidence equal to 0.85. The reason for choosing the above mentioned support and confidence is depicted in the figure shown in the slide. We obtained two rules that fit the threshold criteria. The observed lift values for these two rules is greater than 1 and hence they are considered as good rules. The association rules that we got are depicted in the slides.
These are the challenges that we faced during our implementation. Selection of data mining task. Our choice of the data mining task was crucial in deciding how significant our results were. Since our data set was based on transactions, we thought a market basket analysis would give us the most useful results. Our data set consisted of a number of textual attributes which had to be visualized and modeled. Since they were descriptive and not numeric, we had to convert them into data vectors to use them. We had to try multiple combinations of support and confidence to ensure that the association rules we generated were strong enough. Let us shift gears and move on to a quick demonstration of our implementation. So let's start with our implementation. Our first step is to set up our working environment. For this, we execute the get directory and set working directory commands. Our data set is present in a CSV file. Our next step is to read the CSV file into a data frame called data. Now, we use the summary command to make sure that our data has correctly loaded. As you can see, we can see the summary of all the columns present in the data set. The next step is to filter data related to Germany. For our analysis, we will be considering all transactions that have occurred in Germany. The execution of the summary command helps us to make sure that the records considered in the dataset now are only those pertaining to Germany. As we can see, all other countries show data records equal to 0. Our next step is to remove the duplicates. All of these steps are a part of data pre-processing and cleaning. Here we can see the difference in the number of records present for Germany. Initially, there were 9495 records, and that was brought down to 9480 records after the removal of duplicate values. Our next step is to remove missing values from the dataset. Here we can see that the number of records that are present are 9480. This is because the data set does not contain any null values. Our next step is to make sure that we consider attributes that are required. In this case, of all the attributes present, the only ones that are essential are invoice number and product description. Hence, we will be setting the rest of the attributes to null. This view command helps us to verify that the only attributes that are now considered are invoice number and description. This step completes our data pre-processing and cleaning stage. If we've completed our data pre-processing and cleaning step, our next step is to convert our data from its atomic form to transaction form. To do this, we first aggregate our data. This function is divided in two steps. The first thing that we have to do is combine all products of a single invoice into a single row. Our next step would be separating these items into individual columns. Here, aggregation.csv is a file that contains all our products of a single invoice in a single row. Okay. We are now splitting all items of a single invoice which are currently in a single row into individual columns. To do so, we are using the library split stack shape. We're saving this modified data in a file called transaction.csv. Now that we've written to our file, we read it in a data frame called basket_data. We use the view command to make sure that our data has come in correctly. Here you can see that every invoice number has multiple products associated to it, separated in different columns. Our next step is performing market basket analysis using a priori algorithm. To do so, we're using two packages, arules and arulesviz. Arulesviz will be exclusively used for visualization of our results. Our first step will be to read our transactions from our transactions.csv file into a data frame called basket. Our next step would be to run the a priori algorithm on our data. Here we must, Here we must specify support and confidence. Since we are dealing with a large amount of data, to make sure that our transactions are not timed out, we're also providing min length and max length. As you can see, with the given support and confidence, we have generated rules. We will now display these rules using the inspect function. The inspect function can be used to display association. Here, we've obtained our rules. As you can see, they have an LHS, RHS, a support, confidence, lift, and count. We've obtained lift values greater than 1, which indicates that our rules are strong enough. That's about it. Thank you for watching.